All right, ladies and gentlemen, let's look at chapter 4.2. We're going to be looking at two-way tables. So in this example, we have a two-way table. Remember, tables describe categorical variables. So in this situation, we can see college students by sex and age group. This is from 2003. And these are in thousands of persons. So for example, that 89 that you see is 89,000. And the 5,668, that would be 5,668,000, and so on. All right, so some definitions. First of all, again, two-way table. In this case, it's age and gender are the categories. The row variable in this case is the age of the student. The column is the gender or the sex. Then we have the marginal distribution, which would be the row and column totals. Okay, so marginal distribution, row and column totals. So you notice that the totals are not in the table, so we're going to need to go ahead and add things up and find them. So I'm going to do the rows first. So 89 plus 61, that's 150. And then the next row, add those two together, and we get 10,365. Okay, the 25 to 34-year-old, add those up. That should be 3,493. And then the last row, I believe adds up to 2,630. All right, now I'm going to do the columns. So the female column adds up to 9,321. Again, that would be 9,321,000. The males add up to 7,317. Okay, now the table total. You can either add the two on the bottom or add up the last column, and you should get 16,638. Okay, so remember that means 16,638,000 is what that actual number is. But we're not going to use those zeros at the end. Now, something we talked about in chapter 1. The next term, as soon as I can get this thing to work properly, is round-off error. Okay, we haven't done any percents in this yet. We're going to get there. But remember, round-off error, it is not critical. For example, the percents are supposed to add up to 100%, but they may add up to 99.9 or 100.1 because of rounding to a certain place value. Okay, that could also occur with the counts. Okay, you may end up being a bit off because of rounding error. Not a big deal. All right, so this is what we're going to be working with. We're going to be working with a table of values. All right, now what are we going to do with this? So there can be a number of questions that are asked about the table. In this first problem, we're going to calculate the percent of college students by age group. All right, so if we look at the first age group, let me color code this. So the first age group is right there. Now, it's just saying by age group. It is not saying anything about male or female. It just says that age group. So that means we're going to combine them. So we're going to do the 15 to 17-year-olds. There's 150 of them. All right, well, we're going to divide that by the total, which is 16639. Now, I'm going to put an approximate sign. And when we type this one into the calculator, okay, I'll do this one. We've got the 150 divided by the 16,639, and we get that long decimal. Okay, so we're going to go 3 decimal places on this one, so 0.009. Now, if we change that to a percent, remember, multiply that by 100, so this would be 0.9%. Okay, that is less than 1%. So less than 1% of students go to college that are 15 to 17. There are some, but not that many. All right, let's do the next age group. So the next age group is 18 to 24. So 18 to 24. Again, we're going to take the total for that age group and divide it by the table total. And we're going to get approximately 0.623. And we're going to round that to 62.3%. Well, definitely a majority of the students are in that age group. All right, the next age group. So now we're going to do the 25 to 34-year-olds. 3493 divided by the 16,639. All right, type that in. That's going to be approximately 0.21 or 21%. And then the last one, 35 years or older. 1660 divided by the 16,638, which is approximately 0.158. So we'll say 15.8%. Now let's see if we have any round off error. All right, so I'm going to go ahead and take the 0.9 plus the 62.3 plus the 21 plus the 15.8, and let's see. How about that? It actually turned out pretty good. So we even though we rounded, we still ended up with 100% on that. All right. Next. With categorical data, remember we can make bar graphs. Bar graphs are made from categorical data. Remember, bar graphs do not touch each other. There is a space between each bar. So in this situation, we've got a nice bar graph of the percents that we just found. So you can see the 15 to 17-year-olds is right there, 18 to 24, 25 to 34, 35 or older. So we have a real easy visual, and we can very quickly see that the 18 to 24-year-olds, there's definitely way more students that go to college at that age than any other. Now remember, when you're doing percentages on the side of the graph, that's also known as relative frequency. All right, so you're going to be making some bar graphs. Okay, let's continue. So same table, except this time we're going to do a condition. The condition here is, given an age, what would the percentages be? So if we are interested in just this age group, okay, that's our condition, 18 to 24-year-olds. So we're going to go ahead and look at the female, okay, because we're separating them. It says conditional distribution of sex given age. So we're going to look at the female and male, and we're going to look just at that age group. Well, if we're looking only at that age group, we don't care about the rest of the table. This is going to get into, looking at this, this is going to be big when we get to the probability unit, okay? Because it's almost identical, but right now we're just finding percentages. All right, so we'll start with the female. So we've got 5,668 female, but we're only interested in that age group, so that's out of 10,365. That's approximately 0.547 or 54.7%. Okay, same thing with the male. Okay, only that age group for males, 4,697 divided by the 10,365, and that's going to be approximately 45.3%. Okay, I skipped the decimal there. Now, if you add these two together, they should add up to 100%, 54, because we're only interested in that age group. So the 54.7 and the 45.3, yes, they add up to 100%. All right, let's go ahead and find the percent for the rest of these. All right, so let's go ahead and find it for the 15 to 17-year-olds. All right, so female, male. All right, 15 to 17-year-olds. So it looks like we're going to take 89 and divide it by 150. All right, I'm going to let you go ahead and find that decimal. You may need to pause the video because I'm going to keep right on rolling. For the males, that would be 61 divided by 150. All right, we already did the 18 to 24. So now let's do the other age group, 25 to 34. So let's see what that would be. So 1904 divided by the 3493. And the 1589 divided by the 3493. Again, the condition is the age group, and we're looking at what is the percent for the male and female for that, for each age group. Okay, then we have our last age group, because we already did the 18 to 24. So 1660 divided by 2630. All right, and that's the 35 plus. And then we've got 970 divided by the 2630. All right, so find the decimal, change them to percents. All right, next. This time we are going to make the condition age given sex. Okay, so the condition has slightly changed. Now, here we are interested, let me change my color here. We are interested, so we've got the female, and then we've got each age group. But because the condition is the gender, okay, the condition is gender, we're going to use the column total. All right, so the 15 to 17, that's going to be, so let's see, female. That's going to be the 89 over the 9321.